Our next speaker is Hermida from the University of Hurlingham.
I would like to start from the beginning. That is another topic, poverty. Poverty is a terrible problem we have as a society. Actually, the 10% of the world's population is living in extreme poverty. That means that people can't cover very basic needs. And poverty is not equally distributed across the world, and in regions where, such as Latin America, the region where I came from, poverty is a very important issue because it's associated with various biological, health, developmental, and cognitive outcomes across all lifespan. But let's concentrate in the cognitive and learning outcomes. Socioeconomic status is particularly associated with executive functions. Here in this figure, you can see a recent, no, not very recent, meta-analysis of a couple of years ago, in which it is shown that children from low socioeconomic status homes tend to have lower scores at executive functions tasks across a variety of tasks, a variety of studies, and a variety of cultures. So it seems a robust finding. And it's a problem because executive functions not only are important per se, but also are predictors of academic achievement and other cognitive outcomes. But there are good news. Executive functions are trainable. And the preschool period is considered an optimal time to train executive functions because these functions develops rapidly during the preschool years. So this is my work, the work I and my group conduct in Argentina. We try to identify different types of interventions that can train executive function, especially in low socioeconomic status preschoolers. This is an example of our work. But now I will try to draw your attention to programming, computer programming. Teaching computer programming can be one of those interventions to train executive functions. Where that idea came from? First, because programming requires the cognitive regulation aspects of executive functions. Let's say an example. Typically, people working in computer programming considers that abstraction is a cognitive process that is necessary to think and write proper code. And let's think a minute about this. To make an abstraction, it is to generalize problems into groups by removing the specific information and concentrating in the core aspect of the problem. You, for sure, will need flexibility to flexibly change between the specific problems and extract important information, high inhibitory control for not to be distracted, and working memory to hold in mind all that information and manipulate it. But there are also other indicators that programming could be a good way of training executive functions. For example, there are some studies from neuroscience conducted in adults showing that adult expert programmers use executive functions to program. And there are also a few studies conducted with primary school children suggesting that teaching programming can train executive functions in primary school. So considering all that, in this study, we analyzed two questions. The first one, does teaching programming improve executive functions in preschoolers? And the second one, is that effect higher in low socioeconomic status children or schools than in medium socioeconomic status schools? To analyze that, we conducted a typical intervention study with a pre-post evaluation and a random assignation of 5-year-old classrooms to two groups, a programming group and an art group. Both groups received 12 lessons, and all lessons included technology, included tablets. The difference was the content, programming or art. Before and after those sessions, children were evaluated with a battery of 5 executive functions and other cognitive processes tests. Let's see the design more in detail. So in the first step, we conducted interviews with parents across 2 schools to check the socioeconomic status of those families, and from that we selected 2 schools. One of them was a medium SES school. The other one was a poor school. Once those schools were selected, we trained teachers in one of 2 sequences of activities, programming or art. The training lasted 5 sessions. And also, we conducted a children familiarization with technology, because in Argentina, not all children have tablets at home. I would say that most children do not have a tablet at home. So we conducted a familiarization to avoid any potential confounding variable there. After that, we selected a medium socioeconomic status school and a low socioeconomic status school. These are the sample size of each classroom, and classroom, not children, classroom, were randomly assigned to, were first pre-tested with a battery of executive functions, and later classrooms were randomly assigned to programming and art. After that, a post-test was conducted. And here we have some pictures of the activities itself. The activities were carried out by regular teachers in the classroom and were completely compatible with the national curriculum of my country. So here you have pictures. For the programming activities, we used the tool Scratch Junior, a widely used platform for teaching programming in young children, and we used the animated genres curriculum, a curriculum that is also widely used for teaching programming in preschool, and that was designed by Tufts University. Instead, for art activities, we use free painting tools available, like Kids Paint and Doodle Magic. But the activities had the same structure. All the activities had an introduction in which the teacher asked previous knowledge about the topic in hand. Later, the activity was developed, and finally, teachers tried to make a conclusion of the activity, how difficult it was, what was the part most difficult for you, etc., etc. That structure was maintained across both activities. The difference, the art and the programming activities, the only difference was the content. Here, there are the tests we used. There are gold standard tasks. We used for evaluating executive functions. For sure, you already know them. We evaluate attention, high inhibitor control, flexibility, spatial working memory, planning, and nonverbal intelligence with computerized tests. Here you have a picture of the testing that was conducted in schools with the research assistants that gave verbally the instructions to the children. So, what were the results? Here you have them. We run a generalized linear mixed model, and what you are seeing here is the probability of improvement in executive functions from pre to post tests for both groups. Sorry. The blue area is the posterior probability for the programming group, and the gray area is the posterior probability for the control group. In the bottom panel, you can see the poor school. In the upper panel, you can see the medium's SCS school. So our first question was, does teaching programming improve executive functions in preschoolers? So the answer, based on data, is generally yes. with caution, because the gray areas are a part of uncertainty on the probability, but in general, yes, except for planning. In planning, clearly, there was no effect. But in general, there was effect, and especially there was a big effect in division and flexibility task. Here we found a 90% higher probability for the programming group, and with a 99% of credibility. So this effect is really robust. And the second question was, is that effect higher in low SES schools than in medium SES schools? And the answer is yes. As you can see, there is more blue area in the bottom panel than in the upper panel. So overall, we observed a higher probability to improve executive functions from pre to post-test for the programming group in comparison with the art group. This is in agreement with the previous study conducted in primary school showing an effect of teaching programming and executive functions. One question is, why did intervention impact most in the low socioeconomic status group? And here we think, based on various previous studies showing the same, that poorest children tend to benefit more from interventions that are aimed at training executive functions. Another question is why there was no effect on planning. Actually, I was the person that was most convinced that we will find an effect on planning, and data didn't show that. And we think that that was because programming activities in kindergarten are so simple in comparison with programming activities for older age people that could be solved by trial and error. It means planning was not probably demanded for the curriculum. Some children might have planned, others not, but for sure children could solve the activities by trial and error, and maybe that's the reason why we didn't find an effect on planning. Well, this study, as anyone, has a lot of weaknesses and strengths. Between the weaknesses, we can mention the potential teacher's effect. That is, because we have only one teacher in each school and each group, we don't know how much of the effect is due to the teaching style. Although in some processes we found like an effect in both schools, so in that case we can say there was no teaching effect. But anyway, it remains unclear. And also we didn't make a follow-up, so we don't know how much and how long those effects will remain. But this study had some strengths. First, we had an active control. You know, it's much more difficult to observe effects when you use an active control group. Also, and very importantly, we control for technology use. That's important because we are sure that this effect is not due to the mere use of technology, as both groups use technology. Also, we included a comparison by socioeconomic status, which is absent in the literature of teaching programming effects on cognition. This study has a high ecological validity. Remember that it was conducted in public schools, carried out by regular teachers, and the activities are completely able to be applied in any regular school. And also we have practical implicances that are the concluding remarks. First, teaching programming in the school is something that is being included in the curricula worldwide. So it's not this is not an intervention I designed to see the impact. This is something that is already happening. I just measure what is happening in cognition as with the introduction of programming in the school. Our results suggest that teaching programming from preschool could be a way of training executive functions, which is especially important for low SES children. programming in preschool can be taught by regular teachers with just few hours of training. It's not something very difficult to do. However, more studies are needed to replicate this finding and to scale up this intervention. Thank you very much for your attention. This is the team. Here you can download the preprint. This is my website, my email. I would love to receive comments, suggestions, critiques, whatever. And this is those are the institutions that are supporting us. Thank you very much, and thank you for the invitation to this beautiful conference. Thank you.
Thank you. Thank you for the talk. We have some time for questions. I see a first question here.
Hello. Thanks for the talk. I wondered if you had some demonstration of the type of intervention in programming, because I don't really imagine exactly what type of exercise you do with the children. Yeah.
I have a video that I can't show because I don't have the permission, but I can show you now if you want to see how was the intervention itself. But the intervention was like this. For example, most activities in the first step included a body demonstration. For example, let's say, oh, if I have to, a typical activity was that the teacher itself became the character to be programmed. So imagine, I am the teacher, and you are the student, and I can say, what's your name, sorry? Joan. So, Joan, I have to move to the water. Tell me, what are the instructions to move to the water? Turn right. Turn right. Those were the kind of activities. Those activities usually require executive functions, and I can tell you why. I will continue with your instruction, but if you don't say stop, I can say bye-bye and so now, what I have to do? I like it. But children have to think when to stop, don't be distracting, you know? Maybe it's those were the kind of activities. After that, the same activity or something similar was carried out in the tablet. So they had to move a character from one point to another using specific instructions. The Scratch Junior tool is a block programming tool. It is, children do not have to turn right, of course, because they don't write this age, neither read. But they move blocks, like one arrow, two arrows, each arrow resembles a step and stuff like that. Not sure if I answer your question.
We have time for one more question. There is one here, Claire. And if you have a question at the back, please stretch your hand. It's a bit hard to see.
Hi, thanks. It was a really good talk. I was just interested how quickly after the Scratch session that you then tested their EF. So was it immediately after their training or was there a delay?
The post-test, yes. It was immediately after the post-test. So because of that, it's a big problem. We don't have a follow-up. But we immediately after was not like the next hour, was the next week. But yes, it's immediately after. The total time of the intervention, the 12 lessons, were during 3 months.
Do we have more questions? Yes.
Thanks for the talk. So similar to the question of Joan, so was the art session intervention similarly structured as the programming, or was it a little bit less structured, more like, oh, you can draw a giraffe, for example, and that was kind of it? Because I'm wondering if the structure and following particular steps, that's really what is making the effect.
Well, that's a great question, and I can't give you a 100% sure answer, but I can tell you that we made our biggest effort to do the structure of the activity as similar as we can. For example, in the art activities, I have some pictures later. I don't have time now to show you, but we'll be happy to show you later, in which, for example, one of the tasks, like in parallel to the task I show you, was that the teacher was like this, and children had to draw and stuff like that. However, I have to say that at the end, the art activities resulted much more in creativity. Conducting studies in schools have some problems with controlling some variables, because you can't enter in the school and say, you will do exactly that. So we gave a guide to the teachers, but so of course each teacher in a marching moves. And teachers with interpreted art as creativity. So they do not put too much emphasis in controlling variables, you know? Of course there was a control thing, because children have to not to throw the tablets to the partner, but they have sometimes models to copy, or they read the story and they have to draw the characters. But let's say that I think that the programming curricula was a bit more demanding of cognitive control. Thank you. Great questions.
The time for questions is up. Thank you again, Julia, for the great talk.
My pleasure. Thank you.